Hello, calculus students and any seekers of truth. Welcome to the lesson on related rates, the continuing lesson, and we're just going to keep on moving along here with some more examples. So let's look at this one. A conical tank with vertex down is 10 feet across the top and 12 feet deep. If water is flowing into the tank at a rate of 10 cubic feet per minute, find the rate of change of the depth of the water when the water is 8 feet deep. So think of it this way. Here you have a tank. Kind of a weird looking tank. In real life it's probably not this simple, but they made this simple for this particular calculus problem. So it is 10 feet across, so across here that's 10 feet, okay, and it's 12 feet deep in total, 12 feet, okay. And you can imagine there's sort of like a faucet that's pouring water into this thing. Let me draw this faucet a little bit better here. Okay, so there's a faucet that's like pouring water into this thing, and the water is flowing into this thing at a rate of 10 cubic feet per minute. Okay, and then of course as it's flowing into here, you know, it's starting to fill up. It fills up there, and then a little bit later it fills a little bit more. Okay. So the water starts to fill up. Now the question is, when the depth or the height equals 8 feet, okay, how fast is the height of this water changing at that very instant? Okay. So to look into this, we have to understand the relation and the formula for the volume of a cone, and the volume of a cone is 1/3 pi r squared times the height. Now, what's important to see here is that we have three variables: the volume, the radius, and the height. And we really only know enough information about the volume and the height. Notice here that in the problem they tell us nothing about the radius or how the radius changes. And so if we try to solve this problem as is, we're going to have to use the product rule. We've got to have to use the product rule. But that's going to lead us to some problems. So I'm going to solve this problem the right way, and then I'll go back and I'll show you why the other method leads us to some very difficult issues. Okay. So the trick here is to convert. I'm writing off the screen, I'm sorry. We're going to convert R to H. Okay. In other words, we're going to reduce the number of variables that we have to work with. Now, in some cases, you might have enough information to keep all three variables. In this case, you actually don't have enough, and it's just simpler if you can reduce it to two different variables. So let's take a look at this picture. All the way across the top is 10. So that means the radius is 5. Right? The entire size of the cone, or the entire height, is 12. So the question is, and this is a right cone here. So the question is, at the moment that the radius, or at the moment rather, that the height is 8, what's R? Okay. That's what we want to do. That's what we want to solve for, so that we'll be able to simplify this problem. Oh, sorry, I don't want to use 8. I'm going to use 8 later. Okay, so at this moment, so I should call this H. Okay, I'll explain that. Let me explain that again. So the green part represents the fixed size of the cone, and the red part represents the changing size of the cone. In other words, the changing water as it fills up this cone. Okay, so now we want to create some sort of relation between H and R, but we can just use similar triangles. So you can see here that R over 5 is equal to H over 12, so that means R is equal to 5H over 12. Okay. And this little fact is going to make our lives a lot easier because we can take this and substitute it into here and reduce this problem down to just two variables, one using the volume and the other using the height. Okay. So now we have the volume is equal to 1/3 pi. R squared is just 25 h squared over 144 times h. Some more simplifying going on here, so this is 25 pi over 3 times 144. I'll figure out what that is exactly a little bit later. That's not that important. Times h cubed. Okay. Now we can take the derivative of both sides, and I'm going to use just a slightly different notation so you get familiarity with it. dv over dt. This is the same thing as, so I'll make a note here, like dv over dt, is the equivalent of v prime of t. Right? This is just a different calculus notation here. Okay. So this is equal to 25 pi over 3 times 144 times 3 h squared dh over dt. So remember, what we're doing here is we got to use the chain rule. And this 3 conveniently cancels out for us. And now we can go back into the givens in the problem and try to solve for some of the missing pieces. So let's see. The water is flowing into a tank at a rate of 10 cubic feet per minute. So that means dv over dt is 10. This stuff is still there, 25 pi over 144. Find the rate of change of the depth of the water when the water is in fact 8 feet deep. So h here is 8, so that's 8 squared dh dt. Okay. So now we've gotten all the hard stuff done. Just got to solve this equation, and this gives me 10 times 144 divided by 64 times 25 pi equals dh over dt. Now, if this was a non-calculator exam, you would have to kind of fight through this and try and simplify as much as possible. For now, we'll focus on the concept, so let's just put this into a calculator and see a decimal approximation that we have. So this comes out to 9 over 10 pi, and then the units here would be feet per minute. Okay. In other words, at the very instant when this water is 8 feet deep, it's changing at this rate. So I invite you to look back at this problem now and see all the steps and see all the givens and see how it was used. Okay. I'm going to continue. I'm going to do this problem again, and I'm just, I know this is a bit overkill sometimes, but I'm just going to show you why it's very problematic. So you certainly don't have to copy this down. Don't want to copy down the wrong thing. But let's look at a very problematic approach. This is mathematically correct, but ultimately unuseful. So suppose we didn't convert R to H, right? Suppose we didn't do that. Let's take the derivative of both sides. Now we get dv over dt is equal to 1/3 pi. And now we got to use the product rule in here. So the derivative of the first, which is 2r times dr dt, times the second, which is h, plus the derivative of the second, which is dh dt, times the first, which is not pi, I already got pi out of there. This is r squared. Okay. And this expression here is correct. This entire expression here is exactly correct. However, you can try and solve for certain things here. So let's look at this. Okay, let's look at dv dt. We know that this is 10. This is 1/3 pi still. 2r, we'll get back to that in a minute. We know that h is 8, okay, plus dH dt, that's what we're looking for, times r squared. Okay. Now you may ask, well, if I know h is 8, can't I use that somehow to figure out what r is? Well, sure you can. You can use this equation to figure out what r is. So you could put in 8 for h, so we can get r over 5 equals 8 over 12. R over 5 equals 2 over 3, so r equals 10 over 3. Sorry, I'm writing off the screen there. Okay, so now I can take this and put it back into here, and now I get 10 equals 1/3 pi 2 times 10/3 dr dt times 8 plus dH over dt times r squared, which is 100 over 9. Okay, and now we still end up with this problem. dr over dt. How are we going to be able to solve for that? Well, if you want to solve for that, we could still go back to this equation right here. R equals 5h over 12. So that means dr over dt is equal to 5/12 dH over dt. Okay. Then I can take this result and plug it back into here. Okay. So now I get 10 equals 1/3 pi 2 times 10/3 times 5/12 dH dt times 8 plus dH over dt times 100/9. Okay. And now we just got to take this problem and solve for dH dt. Okay. So you see, there's actually nothing mathematically wrong with this. It's just incredibly tedious. So once you're done solving for dH over dt, you will in fact finish the problem with dH over dt is equal to 9 over 10 pi. Okay, so this is an alternate way of doing this problem, but it's much harder. It's so simpler, or not so simpler, but a little bit simpler if you take this expression and you make the substitution in here. We want to use as few variables as we can in these related rates problems because it's going to make things a lot easier for us. Okay. Well, we'll end it there. Thank you for watching and have a wonderful day.